Okay, if you have any question, just let me know. No questions? Munit? Am I audible?
Yes, sir.
No questions?
Sir,
Yeah, Aditya.
in yesterday's lecture, in some places we wrote BH plus not by B is equals to H plus. So, I
Not
mean,
H plus, it also involves Ka.
yes, sir, that equation. In that, the BH plus was initial concentration and the other one was
That
instantaneous.
also,
So,
no, you can take that B naught also. Okay.
okay. Hmm.
Any other questions? No? Did you solve tutorials? तो सॉल्व किया या नहीं किया?
नहीं सर, लाइक इनिशियल ट्यूट से किया था। अभी रिसेंट वाले का तो 2 क्वेश्चन, एक क्वेश्चन अपने फोर्थ वाले का तो एक आपने क्लास में पहले दिया था और एक कल ही दे दिया था। वो रुंगा काटा मेथड वाले बचे थे, आरटी मेथड वाले बचे थे, आरके मेथड।
RKM method, okay. Okay, let's go and solve tutorial. Tutorial 1 was quite simple. What about tutorial 2? Did you solve tutorial 2 question number 1? Okay, so why not let us go and try to solve it. Few questions. Okay, so what is given? This is the reaction A to P, and this is question number 1 of tutorial 2. Okay, and then it is written that reaction is order is half. Okay, with respect to A. Okay, then you have to express this equation. So suppose we have been given some measurement like y0 for any physical parameter which is proportional to concentration of concentration y0, yt, and yt, and then y infinity is given, and then initial concentration. So this is given, and so you have to express the differential rate law. Integrated rate law. Integrated rate law in terms of these things. Okay. Okay, can you do it? Did anyone try?
So over here, why is that same thing, right? Matlab, like you gave another formula earlier also about why.
Yeah, why
It's
is
basically any physical quantity like that.
a physical quantity? Khushi, did you solve this question?
सर क्योंकि नोट्स में सिमिलर चीज हुई थी तो मैंने तो नहीं ट्राई किया था ये। मतलब मुझे वो वाली चीज ट्राई कर रहा था मैं जो नोट्स में मुझे नहीं था, मतलब इसलिए मैंने नहीं किया
नोट्स
था।
में नहीं था मीन्स
जैसे कि ये क्वेश्चन ऐसे टाइप का अपने नोट्स में कराया था, क्वेश्चन नहीं पढ़ी, तो फिर मुझे लगा कि ये बाद में करेंगे, तो पहले मैंने लाइक फोर्थ क्वेश्चन ट्राई किया था और थर्ड क्वेश्चन वैसे वाले।
Okay, so why not try this?
यस सर।
सर
Yeah, Aditya.
इसमें y जो प्रॉपर्टी है वो a और p के लिए अलग अलग कॉन्स्टेंट्स माने जाएंगे ना?
नहीं
या
नहीं नहीं, this is the total.
टोटल कंसंट्रेशन।
Yes.
ओके।
Anyone? Nikita, did you do that?
Yes, sir.
You have already done it?
Yes, sir. I have tried it and done it.
Okay. Pritam,
Yes, sir. I solve it.
you solved it. Okay, so it is not very difficult. Okay, so can you see the slide?
यस सर।
Okay, so y infinity minus yt by y infinity minus y naught. This I have already told that this is always equal to a by a minus x. Sorry, a minus x by a. Is this okay? If you remember that, that's what we did. Y infinity minus yt divided by y infinity minus y naught is equal to a minus x by a. Or you can simply write, this is valid for any reaction. What I mean by is that it doesn't depend on the order. So this is a not by a by a naught. Now for a half order, you just solve this. dA by dt is equal to ka half. And then, so what will be dA by a half is going to be equal to k dt. So what will the integral of this is? क्या होगा इसका इंटीग्रल? a माइनस हाफ का इंटीग्रल क्या हो गया?
2 into a half.
2 into 2 into a half. Am I right?
Yes.
Is equal to kt plus constant. और क्या होगा? कांस्टेंट की वैल्यू क्या होगी? टू ए हाफ. कांस्टेंट की वैल्यू क्या होगी?
सर माइनस कैसे आएगा?
क्या? ओके, माइनस के टी आएगा. यू आर राइट. ए हाफ बाई हाफ होगा ना, सो देयर विल बी माइनस साइन हियर. एम आई राइट? So ये पूरा क्या हो जाएगा? Can I write like this? Is this okay?
Yes, sir.
Yes, sir.
Yeah. So to take this common to a half, what you will get? 1 minus 2 a by a not half. Is this okay? KT. And this we already know. Put this value from here. And you will get the answer. Is this okay?
Yes, sir.
Okay. Anything else? Let's go to tutorial 3.
So,
Yes.
so when we found that y infinity minus yt upon y infinity minus y0 equals a minus x upon a.
Yes.
So here we assume that the property is only in A, not in P.
No, no,
Didn't
no.
we?
Go and check my earlier lecture. It is valid for, it is valid for any physical property. In this, the contribution is from both A and P.
Oh, okay, sir.
Okay, just look at it. And it also, even if I discuss several different cases, and in each case, this equation is valid. Go and check my earlier lectures. Okay, this is always true. I showed you that for pressure, I showed it for conductivity also. In pressure, the constant is going to be same for A and P. But for conductivity, constant is going to be different for A and P. Okay, in that case also we proved that this equation y infinity minus yt by y infinity minus y0 is equal to concentration of A at given time divided by initial concentration of A. Okay. Okay, so next question is, let us go first.
So in tube 2, like in question 4,
Yeah.
it is like not given which reaction is slow step or that. So do we have to directly assume?
Just assume that the steady state approximation can be applied.
Okay. Okay.
That's all.
Okay.
Don't have to, assume that some step is the rate determining step.
ठीक है sir.
Okay. Okay. Anything else?
So like third वाले का मेरा आंसर मैच नहीं किया था.
थर्ड वाले का आंसर मैच नहीं किया था.
नहीं सर, किसी और से पूछ लो, अगर उन लोगों का किया हो तो ठीक है. लाइक मैंने एक और 2-3 लोगों से पूछा था, उन लोगों को मैच नहीं कर रहा था, तो मैंने सबसे नहीं पूछा. लाइक किसी और का
I think this is quite easy question.
यस सर, बहुत इजी था, इसीलिए मतलब मैंने मेल नहीं किया आपको, मतलब पर.
Okay. So I will solve this because here I cannot solve it. So and then I will send the answer. Okay.
हाँ सर, ठीक है.
But it is not that difficult. Okay.
यस सर. हाँ सर, मतलब
next question is, okay, so why I want to go to tutorial 3, because there are 2 questions in that, which is a bit tougher, but not that tough. Let me see. There is. Okay, so there is a question. Let me ask this. Knowledge of the rate law of a reaction, true and false बताना है इसमें. Tutorial 3 का question number 1. Knowledge of rate law of a reaction allows us to decide unambiguously what the mechanism is. Is it true or false?
So false.
Yes, Aditya. That's true, because you see, it is not always that we will end up with only one mechanism. Okay, so please keep that thing in mind. You may end up with more than one mechanism. And after that, we have to look at some other, proof to know that, the out of those 2 or 3, which one is the right mechanism. For example, you can look at the intermediate, presence of an intermediate. Okay. If the partial orders are equal to corresponding coefficient in the balanced reaction, the reaction must be elementary. Is it true or false?
So false. Partial order मतलब like order with respect to the individual component. No?
Yes.
False.
Yeah, it may be more than one step. It can be of more than one step. Okay. There is chances that it can be elementary, but it is not always true. Okay, 2-step reaction, A going to I going to P, can be distinguished from the reaction A to P kinetically if K1 is quite greater than K2. Pritham, tell me, true or false? Is Pritham here or not?
Yes, sir. I am here, sir.
Okay, so tell me.
First reason. I don't
Yes.
think so, sir. False,
Yeah.
false, sir.
Why?
Sir, because for A to P, then rate constant should be K1.
Okay.
But here, when K1 is much greater than K2, then we can neglect K1 and rate constant for P will be K2. So doesn't match, I think.
Yeah. So what in this although means you are right in a sense, but answer is not complete, in the sense that here what we check is how A changes with how how consumption, by what rate consumption of A takes place, and at what rate consumption of formation of P takes place. So in the first step, what is the rate of consumption of A? Palak, what can be the rate of consumption of A? Palak? Nikita?
Sir, K1 into A का concentration.
K1?
Into A का concentration.
Okay, no, yeah. So I'm just asking about rate constant. So it will be K1, am I right? And how does P form? By which rate constant?
Sir, K2.
K2. Okay. In case of AP, what will happen? product formation and your consumption of A, it will have same rate constant. Am I right?
Yes, sir.
Either you take consumption of A or take formation of P. And that's how we can differentiate between two-step reactions. So if rate constant of consumption of A is same as rate constant means different than rate constant of formation of P, then we know that there must be an intermediate. Am I right, Kritam?
Yes, sir.
Okay. The next one is the number of positive terms in the rate law is the number of independent parallel pathway. Khushi?
True.
Prajwal?
True.
True. Yes. Suresh? Is it
Yes,
right?
sir, true.
Oh, okay. Okay, so that's okay. Let's go to question number 3. Tutorial 3. How many of you have solved it?
Sir, I tried it.
You are not able to solve?
No, sir, but I try. I
Okay.
not get the final answer. I got the equation, but I don't know how to maximize the concentration. I am undergoing differentiation. After that, I am not able
Here
to find out.
you need to do differences, and I will just let you know how to do that. Suresh, did you try it?
No, sir.
No? Anyone who have tried and solved it?
So instead of differentiation, can't we directly argue that as the time goes on,
Yeah, that can
the
be. Okay, so let us go there and I will solve it. Okay, so question is, what was the question? That a drug administered to a patient usually is consumed by first order process. Suppose a drug is administered in equal amount at regular interval. An interval between successive doses is equal to 1 by n for the disappearance process. Okay, so let's calculate what will be the t time for 1 by n. That will be, since this is first order, that will be 1 by k ln n by n minus 1. All right. Or you can simply let us write here ln a by a minus a by n is equal to t into t1 by n into k. So this is log 1 by 1 minus 1 by n is equal to t 1 by n into k. From that you can get this thing. Okay. And then you can simply write let us think. At first you have started with a naught. So initially you have a naught. After t1 by n, what you will get? A concentration of A t power 1 by n will be equal to a naught 1 minus 1 by n. Am I right? So a naught minus a naught by n. Now second 2t by n, what you will get? A naught, am I right?
1 minus 2 by n.
1 minus 2 by n, इसका 1 by n हो जाता है,
इसका 1 by n, हाँ 1 by n स्क्वायर,
क्या होगा स्क्वायर, नहीं, this is the initial, so a naught 1 minus 1 by n multiplied by 1 minus 1 by n, isn't it? So 3t by n वैसे ही होगा 1 minus 1 by q. So total a क्या होगा, total a at a given time, क्या हो जाएगा, a at given time is, उस टाइम पे a नॉट दिया था, उसके पहले जो a नॉट दिया था, क्या हो रहा है, पहले मैंने एक दिया फर्स्ट इंटरवल, सेकेंड इंटरवल, थर्ड इंटरवल, वी आर एडिंग a नॉट, राइट। तो मान लो फोर्थ इंटरवल पे आप कर रहे हो, तो यहाँ पे हमने a नॉट डाला था, तब तक यहाँ का क्या हो गया, यहाँ पे पहुंचने पे a नॉट 1 minus 1 by n, और ये जब यहाँ पे इस टाइम इंटरवल पे पहुंचा तो a नॉट 1 minus 1 by n स्क्वायर, दिस वन, तो ऐसे करके यू विल राइट a नॉट 1 minus 1 by n प्लस a नॉट 1 minus 1 by n स्क्वायर प्लस डॉट डॉट डॉट. Now take common a naught, and what you will get, 1 plus 1 minus 1 by n plus 1 minus 1 by n square plus dot dot dot. So what will be sum of this? क्या होता है ये, 1 plus x square. What will you get?
1 upon 1 minus x.
1 upon 1 minus x. Is this okay? And this is equal to
n.
n. And that's what was the question. अब समझ में आ रहा है? So you see here, what is the question? Let's again. A drug administered to a patient usually is consumed by first order process. Suppose that a drug is administered in equal amount at regular interval. So A naught you are giving at a regular interval. A naught. Okay. And the interval between successive doses T 1 by n. Okay. So prove that maximum concentration of the drug in patient body is equal to n times the concentration produced by an individual dose. Okay, simply you know that A T1 by n. So suppose here I am taking it. So from this to this step, इसी डोज का अभी इफेक्ट देख रहे हैं, A naught. So that will be A T1 by n is 1 minus 1 by n. इस डोज का इस टाइम पीरियड पे देखें, मीन्स 2t by n. So a naught plus 1 minus 1 by n square. Am I right? And suppose I am calculating at the fourth step. So what I will write, a naught अभी दिया हमने, इसके one step prior to one the dose which has been given one step prior to this stage, that will give you a naught 1 minus 1 by n. 2 step prior, a naught 1 minus 1 by n square. 3 step prior, a naught 1 minus 1 by n q. And then आपको simply add करते जाना है, and then you will get something like this. So it is dependent on n. So it is not that maximum you will get, after that you will not get. It will n increase करते जाओगे, ये बढ़ता जाएगा. So this is simply n a naught. Is it clear? Any question here? Okay, next question is question number 4 of tutorial 3. Okay, so we need to, here it is given 2A to D. And relaxation time, again I told that to practice it. So what will happen? So let's write A equilibrium and then D equilibrium. Okay, then if I do that A equilibrium minus 2x, then this will be from x at a given time. So if I write d by dt, ये क्या होगा? x बना, it means d equilibrium plus x. So d by dt is k1 into a square minus k minus 1. ये किया था किसी ने? K minus 1 into d. Or simply you can write k1 is a equilibrium minus 2x square minus k minus 1 d equilibrium plus x. So this is your k1 a equilibrium square minus plus k1 4x square minus 4 k1 a equilibrium into x. Will let me know if I am doing something wrong. K minus 1 d equilibrium minus k minus 1 x. Is this okay? Okay, and then at equilibrium क्या होगा ये? K1 A equilibrium square minus K minus 1 D equilibrium should be equal to what? 0, because this is at equilibrium. So d equilibrium by dt. So this 0 means this term you can take it out, and both equilibrium term you can take it out. Sum of these two will be 0. So what is left is 4 k1, yeah, okay. So this x square, x is very small, so this x also can be neglected. So what is left is 4 k1 a equilibrium into x, then minus k minus 1 into x. And this you can also write dx by dt, because dd by dt is, if you look at d is d equilibrium plus x divided by d by dt. Okay, and d equilibrium by dt is 0, so it is simply dx by dt. So dx by dt is given by this equation. Or simply you can write minus 4 k1 into minus 4 k1 a equilibrium plus k minus 1 into x. So what will the relaxation time? Inverse of relaxation time should be equal to this. Am I right? So let us go and write 1 by tau. This is relaxation time is equal to 4 k1 a equilibrium plus k minus 1. Sorry, yeah, it is okay. K minus 1. Okay. Now, if you want to remove this equilibrium, what we can do is we write tau square. That's what we need to prove. Is equal to क्या हो जाएगा? 16k square a equilibrium square plus k minus 1 square plus 8 k1 k minus 1 A equilibrium. और A equilibrium को क्या लिख सकते हैं? A equilibrium square plus k minus 1 square plus 8 k1 k minus 1. What is A equilibrium? If you look at A equilibrium can be written as A equilibrium is equal to
8 anytime.
क्या लिखा था क्वेश्चन? लेट मी सी. S naught is 2D plus A. So here it is written that it is given in the question. If you look at that, कहाँ पे दिया हुआ है क्वेश्चन? S naught is equal to
2D plus A लिखा है.
S naught is equal to 2D plus A. Am I right? So what you can write is D is equal to A equilibrium will be equal to S naught minus 2D equilibrium. Is this okay? So just put here k1 square A equilibrium square plus k minus 1 square plus यहीं पे लिखना था 8k1 k minus 1 into S naught minus 2D equilibrium. So क्या हो जाएगा? k minus 1 square plus 8k1 k minus 1 S naught plus 16 k1 square A equilibrium square minus 16 k1 k minus 1 into D equilibrium. Now you know this is equal to what? 0. Am I right? यहाँ पे देखो, यहाँ पे हमने लिखा है ये चीज. This equal to 0. If you multiply by 16, it is still 0. So this form is 0. And this is equal to 0. So what is left is, that's what you need to prove. इसके बाद it is simple numerical question and you can solve it. Is this okay?
Sir, can you explain that S naught minus 2D equilibrium वाला step?
ये वाला, ये already दिया है question में. If you look at this, question is given that S naught is equal to 2D plus A. Okay.
Yes. Yes.
This has been given already, and you have to express that thing. So you can see here that 2D plus A, what will be 2D plus A? X cancel हो जाएगा. It is basically A equilibrium plus 2D equilibrium. होगा ना?
Yes. Yes.
Yes. So अगर D equilibrium 0 है तो that is equal to simply. So that's why it is expressed like that. So you see that S naught is equal to 2D plus A. 2D is what? 2D equilibrium plus 2x and plus A equilibrium minus 2x cancels out. So S naught is basically the total concentration of A and D. Okay. So this is the way basically, and then there is another question given here, that suppose this solution is prepared like this: 1.43 in 10 to the power minus 5 mole per dm³ and allowed to come at equilibrium. So just try to solve that. I will give you answer also. I believe answer is there or not. No, आंसर दिया था इसमें. मैं तुम्हें आंसर भेज दूंगा what is the answer, but try to solve this. Using this you can solve it. Okay, any other questions? एक बार solve कर लो. If you find any problem, just write to me through email. Okay, I'm seeing if I have any other question to give. Okay, I think RK method थोड़ा सा difficult होगा because you have to solve two differential equation. जो fourth वाले में मैंने दिया था. So एक तो मैंने already करा दिया था. If you have to solve one differential equation, what will you do? That we have already done in class. But if you have to solve two differential equations simultaneously to get answer, then it is a bit complex. But I can, what I can do, I can forward the PDF to you, and even you can find on Google how to solve two differential equations simultaneously with the RK method. That you can do. Okay, but that is a kind of, if you are interested, you can go and try to do it. This is just to know how people solve these differential equations. So for example, in kinetics, you have a differential equation like you need to solve dA by dt, and then you have to solve di by dt. All right, so to get the concentration of I. So I is dependent on concentration of A also. So there are several times you will find out that to get particular value of or value of a particular constituent at a given time, you need to solve two differential equations simultaneously. And in that case, you have to use a different method proposed by RK. And if you are interested, you can go ahead and look at those equations and try to solve it. Okay, otherwise for exam it is not that important. Any other question if you want to ask? Otherwise I will stop.
Sir, in the fourth question of tutorial 4, the RK method question, my concentration at t equals to 0.4 is coming out negative. So, I mean, is it happening in the solution?
So maybe question may have some wrong. I have to look at it. Okay. Please try to do it sometime. There is a possibility that I may have given initial concentration wrong. Okay. So but make it sure that you are doing it in a right way. Okay. So there are two questions, am I right? Tutorial 4, I don't have.
Yes, sir. Yes, sir.
Two questions on RK method.
Yes, sir.
One question you have to solve. I believe that one question in one question you have to solve two differential equations simultaneously. Am I right? Yeah. Let me see tutorial 4. Just 1 minute. Give me 1 minute. Question number 3 is simple. Okay. It is, but if you look at the second question, you need to solve two differential equations because A is being consumed in the first step, and basically it is consumed in two different steps. A to P is the first order, to A to Q is second order. So, so for that, since this is a parallel reaction basically, okay, this is a parallel reaction, and so you have to solve, two differential equations.
But
Or you can solve by, there is only one differential equation. Am I right? But this is second order. I think that this can also be solved. Did you try that? Question number 4.
Yes, sir. I mean, we can write a quadratic polynomial now.
Yeah. I think this is not two differential equations. This is only one differential equation. There was one question sometime I gave to my, in one of the courses which I was teaching. In that case, there were two differential equations which need to be simultaneously solved. This is not two differential equations. Okay, so this can be solved. Did you try the question number 4? Sarthak, did you try?
नहीं हो पाया था सर, मतलब
नहीं हो पाया था,
मतलब नहीं ट्राई नहीं किया था.
ट्राई नहीं किया, ट्राई करो भाई. प्रीतम?
Yes, sir. I tried it, sir. By
क्या
two
हुआ?
method, Randy इस RK method and by this एक और method आपने बताया था सर, parallel reactions में, वो उससे भी ट्राई किया, दोनों से किया था सर. और इससे किया था सर, वही बात है. मैं ये फोर्थ में अटक रहा है, मैं थर्ड में अटक गया था सर. जो थर्ड निकाला, K3 निकाला.
तो थर्ड में नेगेटिव आ रहा था तुम्हारा?
थर्ड में तो आ गया था सर, फोर्थ में वही नेगेटिव दिख रहा था सर. फिर मैंने दोबारा चेक किया, लेकिन हुआ नहीं सर कुछ. फिर मैंने कंसंट्रेशन भी चेंज करके देखा.
टाइम थोड़ा कम करके देखना.
टाइम कौन सा सर? ये वाला 0.8 वाला?
हाँ, फोर्थ का टाइम कम करके देखना. अगर नेगेटिव आ रहा है तो देयर मे बी प्रॉब्लम दैट आई हैव गिवन रॉन्ग टाइम.
फिर तो 1 ही बनेगा सर, एक ही बनेगा. 0.4 तक ही बनेगा.
K1 K2 किसी एक का वैल्यू बढ़ाकर देखना, so that it is positive, and then are you able to solve it or not? Okay.
Okay sir, I tried it.
Yeah. How many of you know programming?
तो सभी लोग कर रहे हैं. तो 113 का कोर्स है हमारा, लाइक, तो उसमें न्यूमेरिकल मेथड.
So why not you just write one program and solve it?
For RK method sir?
Yes, यही differential equation solve करके देखो. Try to solve a few differential equations and see whether you are getting right result or not. Write your own program. Okay, तब क्या हो सकता है कि you can make h very small also. Okay, h means the interval which you are taking. ठीक है? Any other question? Please feel free to write me if you have any questions. Okay? And all the best then. If you don't have any question, all the best for your exam. Okay? Just go through the notes. And if you have any confusion, just write to me. Okay? Okay, then bye.